All right, let's go ahead and get started on 11.6 notes. Today we're talking about factoring things of the form ax squared plus bx plus c, where that a value is equal to 1. What that means is we're just factoring polynomials that have these three specific properties. It has to be of degree 2, which we call a quadratic, so I'm looking for x squared. Next, it has to have three terms, which we know is called a trinomial. If it has 2 or 4 terms, it has to be factored using some other method. And then lastly, for today only, we're talking about specific leading coefficient of 1, which means you should have just a regular old x squared and no number out front. If there is a number out front, however, that might actually have a GCF, which we learned the other day. So looking for these three specific properties, and then today's method will work for those things. So next, I'm going to show you how to do a shortcut on checking your work. We're actually going to use this method over here when we're doing another method with guess and check. But let's go ahead and recall first how to even solve these problems. If I gave you two binomials and asked you to multiply them, you would multiply the first term out, you would get x squared. You would multiply the first and the last term, you would get a positive 2x. Here you would get a positive 3x. And then here you would get a plus 6. So if we have these, we just multiply them all together, then we combine our like terms, so we get x squared plus 5x plus 6. Which is great, and that's correct. But there's sort of a shortcut on how to prevent writing this entire step out. So if while you're doing it, if you multiply just the first two terms together, that actually gives you your a value, which again is still x squared. If you multiply your last terms together, your numbers together, your constants, that's going to give you your c value, which again is still plus 6. But in the middle, instead of actually multiplying them and writing them out, you just do your inner product, 3 times x is 3x, and you do your outer product, 2 times x is 2x. And you can just go ahead and actually add these two values together, and they're both positive because they were both positive. So 3x and 2x together give you that positive 5x. These together, the inner and outer product, actually give you your b value, keeping in mind that ax squared plus bx plus c form. So instead of having to write out one whole long line of work and then combine like terms, we can just write out each of the terms, add them together, and put them straight in the middle. This is how I'm going to check all of my problems today, so I don't have to have 2 layers of work to check my answer. Also, this method is super helpful when we're doing another method later, so definitely try this out today. Also, some people call this the Curious George method. If you add 2 dots here, it looks kind of like a monkey, but I like to just call it inner product and outer product. So that's what I'll be saying as I go through. So let's go ahead and do our first example. So I want to factor this trinomial. My ultimate goal is to make it look like this. If it has a GCF, bring that GCF on the outside and then have 2 little binomials multiplied. So the first step is to always check for a GCF, and that will be your first step from now on for every single factoring problem we ever do. So checking for a GCF, I already wrote GCF over here. I like to do mine systematically. I always check numbers first. So looking at my numbers 2, 8, and 24, are there any common factors that go into all those numbers? Well, I always check the smallest number first. Does 2 go into 8 evenly? Does 2 go into 24 evenly? If your smallest number goes into all the numbers evenly, automatically that is your GCF. If, however, your number does not go into all of them, then you would need to maybe list the factors kind of like you saw in the video the other day. But 2 does go into 8 and 24 evenly, so 2 is part of my GCF. And then go through your factors in alphabetical order. So I'm going to do x's. So we have x squared, x, no x. Therefore, x is not a factor because this guy does not even have an x at all. Look at the next one, y. I have 1y, 1y, 1y. So all 3 terms have a y as a common factor. So 2y is actually my GCF. So I'm going to go ahead and factor out this 2y. I'm going to bring out my GCF. And I'm going to draw one big parentheses. You cannot go straight from here to here. You do have to factor out that GCF and then see what you have left over. So to do that, again, we're going to divide each term by 2y, 2y, and 2y. So a side note here, if you have a trinomial as your first term or your first polynomial, you will have a trinomial inside this parentheses. You're not going to lose any terms. So however many terms you have out here will be the same number of terms you have on the inside. All right, so going through, I'm going to say 2 divided by 2. Well, that's just a 1. X squared divided by no x's, nothing can cancel, so I'm left with x squared. Y divided by y, that's the same thing as y to the first minus y to the first. They're going to cancel out. Negative 8 divided by 2 is a negative 4. X divided by no x's, nothing is able to cancel out, so I'm stuck with an x. And then y divided by y again is going to cancel. Lastly, negative 24 divided by 2 is a negative 12. There are no x's, and y divided by y again is going to cancel. So now I'm left with a GCF and this trinomial that actually satisfies today's rules. I have a trinomial of degree 2 with a leading coefficient of 1. So I'm actually able to factor this. So I'm going to go to my next step. I'm going to draw parentheses and fill in the variable. And don't forget your GCF. So I'm going to go ahead and bring down my GCF. And again, my goal is to have 2 sets of parentheses. So I'm going to go ahead and draw 2 sets of parentheses. And fill in your variable. That variable comes from right here. You ask yourself essentially, how do I get x squared? What times what is x squared? Well, we know that x times x is x squared. That comes from that process above where I multiply the first term together to get my a value. X times x is x squared. What you're going to do next, though, is we like to call this the x method. You're going to draw an x on your paper. And you want to find numbers that satisfy this certain process. I want to find numbers that multiply to be negative 12 and add to be negative 4. A way to kind of remember this process is this negative 12 is your C value, which is kind of like the ceiling of this x method. And negative 4 is your B value, which is kind of like the basement of this x method. So multiply, so I put a dot there, multiplies to be negative 12, adds to be negative 4. So look at the factors of 12. So 1 times 12, 2 times 6, and 3 times 4. Once you've chosen your factors, you can kind of ignore the 12 for a minute and look at just that negative 4. Which of these 2 factors can give me a sum of negative 4? Well, depending on positives or negatives, I could have a 13 or an 11. That's not going to work. Depending on positive or negative, I could have an 8 or a 4 here. So 4 is what I want. So I want a 2 and a 6. But you've got to force those numbers to give you a negative 4. So you got to force the signs to work out. So what kind of 2 and what kind of 6 give me a negative 4? Well, if I made them both negative, that would be a negative 8. So that wouldn't work. If I make one negative, one positive, it is going to give me a 4, but depending on which one you choose, changes whether it's a positive 4 or a negative 4. Keep in mind when adding, the sign of the bigger number is the sign you keep. So I actually want a negative 6 and a positive 2. Okay, so double check that. Is negative 6 plus 2 a negative 4 or 2 minus 6 negative 4? That works. Also double check that your signs actually multiply to give you a negative 12. Positive 2 times negative 6 is in fact a negative 12. So you're good to go. All you do is literally copy this number into your first one and this one into your second one. And you actually are done. This is the correct answer, so I'm going to go ahead and box it off. But we are going to go ahead and check that process. Also, it does not matter at all whether you put negative 6 and a positive 2 here. It doesn't matter about the order as long as you have the appropriate positive 2 and the appropriate negative 6. That's my final answer, but I'm going to go ahead and check my work by distributing. So I'm going to use that method I said above, that Curious George method, or that inner-outer product. So I'm going to bring down my GCF, 2y. X times x is x squared. I'm going to check my last terms, my C value. Positive 2 times a negative 6 is in fact a negative 12, which is what we wanted before. And then to check my inner-outer product all at one time. So positive 2 times x is a positive 2x. And x times a negative 6 is a negative 6x. Just add these two together. Negative 6 plus 2 is a negative 4x. So I did get back what I wanted. You can also double check your final answer by distributing this GCF through and make sure you get back your original problem. So I'm just going to multiply this guy straight through. 2y times x squared is 2x squared y. 2y times a negative 4 is a negative 8xy. And then 2y times negative 12 is a negative 24y. Comparing my final answer with my original problem, I did get back the exact same thing I started with. That's supposed to be a check mark. But again, my answer is actually this. You're done here. Your goal is to have, if you have a GCF, to have some GCF on the outside and then 2 sets of parentheses. So my final answer is here. This was just me checking my work, and we have the correct answer. So we're done. So let's go ahead and work our way through several examples. So starting out, we always check for GCF. So step 1, checking for GCF. Looking at my numbers, I have a 1, a 2, and a 24. So my smallest number is 1, but we don't really care about a GCF of 1 because it's just everything has a GCF of 1 always anyway. So no GCF here. Looking at variables, we have x squared, x, no x's. So therefore, we actually have no GCF. Okay, step 2 is to, if we have a GCF, bring it down, but I don't have one. So go ahead and draw your parentheses and fill in your variable. Again, my variable comes from this very first term when it's in standard form. How do you get x squared? Well, x squared is x times x. Okay, then next to find your numbers, you're going to do that x method. What multiplies to be negative 24 and adds to be negative 2. Okay, if you don't know your numbers, I'm going to go ahead and write my factors. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And again, I've cycled around, so I don't need to check any other numbers. So of these factors, which ones are going to give me a sum of a negative 2? Well, if you look through, this could give me a 25 or a 23. If I add it, I could get a 14. If I subtract, I get a 10. Okay, keep going through, and then we have 4 and 6. 4 and 6 could give me a 10 or could give me a 2. So I'm going to write down 4 and 6. And I've got to decide what kind of 4 and what kind of 6. Well, I want a negative 2. So I want the sign of my bigger number to match the sign of my final answer. And then just double check. Is negative 6 plus 4 negative 2? Or is positive 4 minus 6 negative 2? Either way, when I add these together, I get negative 2. Double check. Is positive 4 times negative 6 negative 24? If so, then you're good to go. Go ahead and fill these guys in any order. I always just go left to right. And that is actually your final answer. But we're going to go ahead and check our work. Checking our work. Always check. This should always give you your x squared. And this should always give you your negative 24. You have chosen those numbers to satisfy that a and that c value. So those should always work out if you actually checked your work here. We're just mostly checking our inner and outer product. Positive 4 times x is a positive 4x. And x times negative 6 is a negative 6x. Double check that positive 4 and negative 6 actually give you a negative 2x. And they do. So I know for a fact that my answer is correct. I'm going to go ahead and stop here and let you guys start the next video.